All right, so number 19 on the midterm review. Um, okay, another proof, and it's going to be one of those corresponding parts of congruent triangles proof. So we'll get the triangles congruent, it looks like, and then we'll finish off where we need to be. So if AB is parallel to CD, that's going to give us some alternate interior angles to work with. BC bisects AD. Now, we know that AD is two equal parts. Can't be certain if anything else it is. Can't be certain about BC, but we can be certain about that. What I look for is, I try to show my students, look for the N or the Z with the, obviously the parallels being your ends of your, so like if you were doing the Z, these are your parallels. If we're doing the N, those are your parallels, okay? And then the inside corners are always congruent because of alternate interior angles. So we can guarantee that these two are the same. There is another pair that would work. We could get those, but I'm going to go with vertical angles just to, use that. So for me, I'm going to complete an angle side angle proof. All right, so here goes. If I'm going to complete an angle side angle proof, I want a pair of angles first. Doesn't matter what we start with. Let's start with the vertical angles. All right, angle AEB, congruent to angle, right, AEB, so through the path DEC. And that's because vertical angles are congruent. Okay, now I can go with, I want to get A congruent to D, but I need some help first. Whoops. I need some help from, the parallels. So let's start with AB is parallel to CD because it was given. Now the conclusion is angle A is congruent to angle D. I don't need a three-letter path because that's the only angle at A and D. So that's by. So some of us use alternate interior angles theorem. You know what? I'll just explain it so that in case some other folks are looking at it, I'll say because alternate interior angles are congruent when parallel lines are cut by a transversal. Some of us use alternate interior angles theorem there, but whatever. Okay, now I kind of went out of order there. Sorry about that. I took care of the angles. It doesn't matter. Um, I'm going to go after the pair of sides. I should have done that before the angles, but all right. BC bisects AD. BC bisects AD. So AD is what got cut in half. Um, so that's because it was given. 5, the result of that, the conclusion from that is that AE is congruent to DE, and that's by definition of segment bisector. If you forget that, it's fine. Just explain when you bisect a segment, you get two equal segments. Okay, now the triangles are congruent. Triangle AEB is congruent to triangle. I did it again. Sorry. What is that? AEB. I got to get the corresponding correct. So D should go with A. That's what I'm trying to look for here, DEC. And that's by the angle side angle triangle congruence theorem. Now, it doesn't matter the order that I proved it in, because the order I proved it in was angle, angle, side. It matters what the diagram says. Angle, side, angle, that the pair of sides are between the pairs of angles that we have here. So I finish it with, again, AB congruent to CD, AB congruent to CD. So 7AB is congruent to CD by, let's get some space here. There's a lot of different acceptable answers out there for this. Corresponding parts of congruent triangles are congruent. So there that is. Okay, and that's what we needed to finish with. So good. All right. This one we could go grab a graph for so you could see this. You know, the rule, this is called the rule, algebraically, of the transformation. So we're going to move to the left 2 and up 3 with every point. Or you could just use the algebra, okay? We could take, here's what we're saying. We're taking 7, 2, and we're going to go 7 minus 2 because this is x, right? So 7 minus 2 goes there. This is y. So then we're going to put y in there at 2 plus 3. So we should get to 5, 5. All right. I'll show that with the graph as well in a second. Okay, so if we wanted to graph 7, 2, it'd be right there. Let's just call it A. And then this should tell us to move left 2, up 3 from there. Okay? And then that's the location of A prime. And if you look at the coordinates, it's 5, 5. So, yep, there's our choice. Okay, continue. All right, this one surprisingly was one off of the test earlier this year, and it caught a bunch of us, which was, again, surprising. Basically what we're saying, the composition or the order in which this happened is your pre-image doesn't have the primes. Okay, so your original is your pre-image. This is where we're starting at. Now, the single prime represents the result of the first move. So this is the image after first move. And if you look at it from here to here, it didn't turn, it didn't flip. They all moved the same amount in the same direction. We should know that that means it's parallel. Sorry, those are parallel. Okay, if every point moves by the same directed segment, it was a translation. Okay, so that's our first move. Now from the second move, it's pretty clear that B prime went to B double prime, C prime went to C double prime. Okay. So this next move, it looks like the points move different amounts and the orientation, okay, orientation's a big deal. Okay, orientation is the arrangement of the letters. So if we go from A to B, A prime to B prime to C prime, okay, what I like to do is circle it, start at A prime, and move to B prime. Okay, that direction is going against the clock, which is counterclockwise. So that's the orientation of that particular diagram. Now, if we go A double prime to B double prime to C double prime, circle it, start at A double prime, move to B, continue to C, back around. That went to clockwise. Okay, changed the direction of the letters, the arrangement of the letters. Now, when they have different orientations, the only transformation that we study that can do that is a line reflection. Okay, so if you go through that, and it's clear it's a y-axis line reflection. So first move, translation. Second move, line reflection. So these should say line. First move translation, line reflection. A rotation can't switch orientation. The first move was not a line reflection. Okay. All right. Okay. So what we're going to have to do is we will have to get some graph to do this one. It's probably the best move. And then we'll figure out which of these sequences would map B. So we'll have B is at 2, 3. I don't know what B prime will be, but then B double prime has to finish at negative 2, 5. Okay, these are all 2 moves. So that's what we're looking to do here. So I'll go get a graph. Okay, so really we don't have to graph the whole thing. Let's just graph 2, 3. And then that's B, right? We got to land at B double prime, negative 2. 1, 2, 3, 4, 5. Okay. That's where B double prime's got to be. All right. If we translate, or if we reflect, let's just try one at a time. If we reflect over the y-axis, B prime lands there. T02 means to go up 2 from where we are. That does work. Little r is reflect. Capital T, symbol for translate. Capital R is going to be the symbol for rotate. So make sure you know all of those. There's line reflect and there's point reflect. They both start with a little r. How do we know it's a line? Because the y-axis is a line. Okay, this is no good. This should not have happened. That should be little r. X-axis. Sorry about that. I don't know what happened there. Somebody typed it wrong. Then translate left 4 up 8. Okay, let's test that out. So we got a yes for this one, but all of them is possibly an option. So we got to check them all. Okay, so let's get rid of that. We got to land. We got to land here. If we reflect over the x-axis, 1, 2, 3, there's the x-axis, 1, 2, 3, there's B prime. And then this says go left, translate left 4 up 8. Left 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. That one works too. Okay, let's just verify it's probably going to happen that this one works as well. Okay, so let's just go through the process though. Translate 02 means right there. Translate left or right 0, but then go up 2, which puts us B prime right there. Okay, and then if we reflect over the y-axis from there, we land on B double prime. So that worked. All of them worked. All right, there it is. Okay, so that will be it for this recording, and there's 1 or 2 more left.